All right. Hey, Carson, this is 8-6. We did the first half of the notes yesterday. We are starting on the back side where the box is. So it talks about average and standard deviation heights of teens. All right. So we have boys' average height. I looked these up. This is based on like a couple years ago. We looked it up. And X bar represents the average, right? That's the average or the mean. They will use this symbol for standard deviation. I most of the time use S as standard deviation, okay? But standard deviation or sigma, that's what that value is. So they're saying the average height of teenage boys is 67 inches, which is 6'7".
What? No, that's
5'7", not 6'7". I don't know why I said that. 5'7". 5'7" is the average for boys. Okay. Go with what I mean, not with what I say. I was just seeing if you were paying attention, right? Average height for girls is 5 foot, almost 4, 5'3.9" inches. So almost 5'4" with a standard deviation of 2.4. Now, the standard deviation for boys is more than girls. What does that mean? Boys have a wider range of heights, okay? And there's more variation for boys' heights. That makes sense. You both are right, okay? All right, so we're going to compare the Reese's. We compared Carter and Ellie. Oh, boy, did we have a throwdown almost. Is it C or S? You guys are both C's. I always get that confused because I have a friend who has a Reese that's an S. So we have Reese, and this is Reese Payne, and this is Reese M. Okay? So we got boys and girls. Boys and girls. All right. Reese Payne was 5'11" when I measured him just now. That means he is how many? Yes, off to the side. Yep. We're actually testing this. 5'11" is how many inches? 5 foot is 60 inches. This is 71 inches. Okay. Reese Malati, what did I say you were? 5'7"? Okay, 5'7". And that would be 67 inches. Yes? Who is taller? Reese Payne, right? Reese Payne is taller, okay? But it's not fair. It's not fair for me to say Reese Malati's shorter because she's a girl. Like boys are genetically programmed to, for the most part, be taller than girls. That's just the way that your genetics are, right? Like, that's not fair. Boys are generally taller. I'm not addressing any questions at this point. Boys are generally taller than girls. That's just the way that goes. So it's not fair for me to say that Reese Malati's short because she's not, right? Like, whatever. She is shorter than Reese Payne. That's just the way that it works, okay? But what we're going to do is we are going to take into consideration their genders and figure out whether Reese Payne is a taller boy than Maddie is a tall girl. Does that make sense? We're going to see who is taller relative to their gender. We're going to see which is which, okay? And so we do this by taking into consideration their standard deviation and their average and stuff, okay? So what I want you to do right here is make a bell curve as best you can. Just draw as best you can, right? Something like this, okay? Draw a little bell curve off to the side right next to where we're talking about here. And we're going to label this. And yesterday I said the average lives in the middle. This is where your X bar lives, right? And then we add a standard deviation, add, and then we subtract and subtract and subtract, right? Okay? So the X bar, in a sense, is kind of like at your 0 station, right? And then when you add one standard deviation, you're at +1, and then you're at +2, and then you're at +3, right? And then you're at -1 and -2 and -3, okay? These numbers here that you have are called z-scores. Okay, z-scores. And a z-score stands for, your z value is the number of standard deviations you are from the mean or from the average. So if you have a z-score of 1, that means you are 1 standard deviation above average, right? 1 standard deviation above average. If you have a -2 standard deviation, you are 2 standard deviations below average. Does that make sense? Okay? So it kind of puts you on a scale, and then we're allowed to compare those things, right? Like I said yesterday, it's not fair for me to compare ACT score to SAT score until I convert them to this same scale, and then I can compare them to see which one is better. Okay? Mean. Okay, so we're going to do this, and the way that we do this is using this formula. Okay, so let's identify what these things mean. X is my value, or in this case, it's Reese Malati and Reese Payne. My value. Okay, X bar, what did that stand for again?
Average.
The mean or the average. Okay, and then this little guy, what was he called? Most of the time we call him S. He is the standard deviation. Okay, that's the formula that we're going to use to find the z-score. The z-score. Okay, good? Yeah? All right, I'm going to bump over here and we're going to find the z-score for each one of these people over here. So z is x minus x bar divided by the standard deviation. I'll write it here again. Okay? All right, we're doing Reese Payne first. So his x value is 71 minus, what is the average? We're looking at average for boy. Go to that box. Do you see that box? 67, and the standard deviation is 2.76. Okay, somebody in a calculator do that for me. 71 minus 67 divided by 2.76. 1.626, so we'll go 1.63. That is his standard, that's his z-score. So this is where Reese Payne lives. Right here, 1.6. He is 1.6 standard deviations above average. Okay? Now we're going to go to Reese Malati. She is 67 inches. Okay? And we're going to subtract, what's the average for girl? 63.9. And we're going to divide by 2.4. That's the standard deviation. Okay, what's 67 minus 63.9 divided by 2.4?
1.29.
1 point what?
291.
Dang it. 1.29. So what does that mean?
Yeah, Reese is taller.
Guys always.
Well, obviously Reese is taller, but which one? Reese Payne, relative to their gender, Reese Payne is still taller. You know what happened in the 6th period class?
What?
We compared Ellie and Carter, and Ellie's taller than Carter, right? That's just the way it works. But relative to their gender, do you know who's taller?
Carter.
Ellie. Ellie is a taller girl than Carter is a tall boy. That's just the way it went. I don't know.
Mrs. Comacher,
What?
you know those prom slip things they gave us? About, like,
Why are you asking me this question when we're doing math right now?
Because they're due today and I don't.
Okay, why are you asking me that right now?
Do you have one?
You can, no.
I bet there's
That's
one
not,
on
I'm not a
someone's
prom
locker
person.
Do you have one?
Okay?
At my house.
All right, so here we go. Example 3. Example 3. We're going to label this step. It says find the z. This is the z-score. It says find the z-score. If my value is an 18, when the average is 22, and the standard deviation is 3.1. Here we go. Let's label it off to the side over here. Which number goes in the middle? 22. And I'm adding and subtracting 3.1. So if I add 3.1,
Did that last one wrong?
25.1. If I add another 3.1, 28.2. If I add another 3.1, 31.3. Okay? All right. Now, what are these guys' z-scores? Like, what's the z-score for 22 exactly? 0. He's 0. He lives in the middle. What's the z-score for 25.1? 1. What's the z-score for 28.2? 2. And this guy has a z-score of 3, right? Okay. Now, if I subtract 3.1,
17.9.
I think it's 18.9. Is that right? 18.9? Yeah. 18.9 if I subtract another 3.1. 15.8, subtract another 3.1. 12.7. Okay, what's 18.9? He is a -1 z-score. He has a -2 z-score. He's a -3 z-score. That's how that works, right? Okay? All right. I am wanting to know, hold on. I am wanting to know if I have a score of 18, what my z-score will be. Okay, where does 18 live on this chart? Right here. 18 lives there, right? Yeah? So what will my z-score approximately be? Something between -2, -1. Whoops. -2, -1. That's what I'm looking for. Okay. Formula for z-score is x minus x bar divided by the standard deviation. So if I'm calculating my z-score, I get, what's x? 18 minus 22 over 3.1. What does that z-score give me? -1 point something.
1.29.
29, -1.29. Is that what we guesstimated it to be?
Yeah.
Yes, right? That just makes sense. It's telling me that that number, if I scored an 18, I am 1.29 standard deviations below average. That's what I am. Okay? All right, now I'm going to skip example 4, but off to the side over here, I'm going to add on one more example. So put this over here. We're still going to use the value of 22 as my X bar. We're still going to use a standard deviation of 3.1. So we're still going off of this scale. But I'm going to flip things around on you. And I'm going to say what value has a Z of 2.25, let's say. What value would have a Z-score of 2.25? Now, let's guesstimate using our bell curve here. Where does 2.25 on a Z-score live?
Right in between.
Right here. So I would have had to have scored somewhere between a 28.2 and a 31.3. Does that make sense? So how do we figure this out using algebra to do this, right? We know that Z is equal to X minus X bar divided by the standard deviation, right?
Would it just be 28.975?
How did you do that? Yeah.
42 point.
Did you split it into quarters and add it to it? Yeah. That will work for this problem, but if you have like a Z-score of like 20 or 2.7, that won't work. Yeah? Yeah. Anyway, okay, so
Or you still could, but you just gotta divide.
you would just have to divide by, yeah. So, same thing. All right, so this one, I know that the Z-score is 2.25. Okay, but what am I solving for? What do I not know? I don't know X, right? Minus X bar is 22. Standard deviation is 3.1. Okay, so
You divide by 3.1.
now hold on a second. If we're solving for X, X is what I'm solving for. This is my formula, and I don't know X, but I do know Z. So I plugged in Z, and I don't know X, right? Now I'm going to multiply by 3.1 to get it to the other side. Yeah?
That's what I did.
Okay, is this 7.75? No, what is it?
It's 6.975.
6.975
3.2.
equals X minus 22. And then what? Add the 22 over. Plus 22. So my value is going to be 28.975. Is that right?
Yeah.
Is that about what we guesstimated it at? 28.975? Yeah? Something of that nature, right? Makes sense? So you can solve for the X if you're given the Z, right? Okay? All right, so go down to the homework assignment. We're skipping example 4. Go to the homework assignment, and you're going to do all of them on the cookie side. You know what I'm talking about with the cookie side? Okay? All right? So they give you what your mean and your standard deviation are up here, right? The mean is 1263. What symbol do we use for 1263? X bar. What's 117?
I bet you it's the S.
S, or sometimes they'll use this symbol instead. Standard sigma, standard deviation, right? So that means 1263 goes here. And if I have a Z-score of, if I'm trying to find the Z-score of 1,000, 1,000 is going to live down over here. So I know for sure his Z-score is going to be
1,000.
negative something, right? It might be -2 something. I don't know. It depends on where my numbers are at. If we subtract, I don't know. Let me have a calculator. 1263 minus 117 is 1146. Minus 117 is 1029. Minus 117 is 912. Okay, so if I'm doing 1,000 chips, where does 1,000 live?
Between -1 and 2.
No.
Between
This is -1, this is -2, this is -3. Between -2 and 3, right? So my Z-score will be -2 point something, whatever, right? You'll have to find that out using the formula. Or is it 2.25?
Wait,
Okay, maybe. All right.
117.
If you add, right, 117,
Sorry.
1263 plus 117 is 1380.
And then 1497.
I should just have you, 1497, you have the last one?
1614.
1614, there you go. Okay, so what is the Z-score for 1400? 1400 lives here. That will be between 1 and 2, 1 point something, right? Okay, so use the formula, but we have kind of a guesstimation of where that number lives, right? Okay, happy with that? Questions? And you're like, give me my calculator back, please, right? Okay, all right, I'm gonna let you go. Say bye, people, in the video.